before you were given the equation, you guys had to pick out the important information, find stuff like this, period, amplitude, and shifting, and then put it onto the graph. And so this is now saying if you know that these are the characteristics of it, period, amplitude, and shifting, could you just give me an equation that represents this? Okay? So we're going to write one sine function, one cosine function. Besides the word sine or cos in the equation, they work exactly the same, so it won't be that big of a deal. So if we are going to write this equation for a sine function, first remember kind of our generic form of the equation is this. Okay? And then we want to take the information and plug them into the spots that we know are appropriate based on that information. Okay? So who sees something written in this information? They give us period, amplitude, shifting right, shifting up, that they know we could put into the equation. Remember? Okay, so A represents the amplitude. Okay, that vertically stretches and compresses our graph. So we know we'll be using a 2 in that position because of the amplitude. What else do we know and could put in there? The shifts. Good. So right pi over 10 means that h is equal to positive pi over 10. So that means this part of it will look like x minus pi over 10. Okay, where the minus was from the formula and then h was positive pi over 10. What else can we plug in there from the shifts? Well, good. Okay, so the up 3 tells me k is a positive 3. So after all of this sine stuff is done, my k is going to be a positive 3. Okay. So most of that stuff's pretty straightforward, right? If you recognize that amplitude is the a value and you've done your work with your h's and k's, those things won't be that difficult. This will be the most difficult thing for us, right? So remember how this worked. What is normally the period for the sine or cosine function? 2 pi. So normally it's 2 pi, meaning if that said the period was 2 pi, I wouldn't want anything right here for the b value because I wouldn't want to change it from what it normally was. I would just want it to be like 1, like the parent function, okay? But this period has been adjusted. 2 pi was multiplied by something, a horizontal stretch or a horizontal compression, and now the period became pi, right? Okay. So I'm just going to put x in here for a minute to hold that spot for us, right? So we're playing this game of like, what is x? What was the horizontal stretch or the horizontal compression? So then x ends up being what? 1/2. So either you can see it right away. If the numbers get more complicated, solve it like an equation. Essentially, to get x alone, you'd be dividing by 2 pi. The pi's would cancel out, leaving a 1 here. So the x is 1/2. Now, does the x that we were using here just immediately become the number that we plug in for b? No. This means there was a horizontal compression, right, where things got multiplied by 1/2, but then what number actually showed up in the equation if we were horizontally compressing thing times 1/2? 2, the reciprocal of that. So that does help us know what goes in here, but not exactly the same. It would be 2. So our final answer for this equation, or for this problem, would be that y is equal to 2 times the sine, and then we'd have 2x minus pi over 10. That's all inside of the sine, plus 3. And notice that I kept my x minus pi over 10 group in the parentheses separate from the b value. Because if they're telling you the shift right, they're just telling you the h. They're not being tricky. Like they've already separated. This was the horizontal stretch or compression, and this was the h. So you want to have them separated too. If you want to, you can do extra work and distribute the 2 in and write that inner stuff a different way, but you don't have to. Okay? Is this all right with everybody? Yeah, Alyssa. So remember, because it's a sine or a cosine graph, we have to know that the parent function usually has a period of 2 pi. So if it says the period is 2 pi, there's been no horizontal or stretching or compressing from the parent function, and we keep this a 1. But the minute they say that the period is different than 2 pi, that means the original 2 pi period of the parent function was multiplied by some horizontal stretch or compression to turn the period into pi. So I used that to write a little equation. This is what you guys did yesterday. When you were given an equation with a 2 here, you took 2 pi and you multiplied it by 1/2 and you got that the period was pi. Today we're saying, you know that you normally start with 2 pi, you know it's ending up as pi, what was the thing that it got multiplied by? And it ended up being 1/2. But that means in the equation was the reciprocal of that, which was a 2. Okay? All right, so we're going to do the same thing below for a cosine. Cosine doesn't work any differently than sine, so that's kind of nice, except for that we have to have the word cosine in the equation. Okay, so notice that the amplitude is 1, so the A value is 1. You don't even have to write that 1. We would assume it's 1 if we just start writing cosine after that. We go left pi. Okay, so that means our H is, I'm going to just leave the B value for a minute because it's more complicated. So it's X minus H. We went left pi, so it's like this is a negative pi, and I'll fix that in a minute, make it easier to see. And then we went down 1/2, so I'd subtract 1/2. So is everybody okay based on the discussion we had before this? Why I was immediately able to plug in like the amplitude value, the H, and the K value. I haven't done the B value yet. Saving that, it's more work. Okay. So are we okay so far with our A, H, and K values? Genevieve? Because it went left pi. So my formula says X minus H. So the X minus is part of the formula, and then H is where we're shifting left and right. Because we were shifting left pi, H is a negative pi, and so eventually this will look like a plus. Okay? As if it were planned. Okay. All right, so what do we do next? How are we going to figure out the B value? We have no idea. We just abandoned ship on the B value. Genevieve? Good. So it's a cosine equation, which means normally it has a period of 2 pi. That period can be adjusted by some horizontal stretch or compression. And they told us it turns out to be pi over 3. Okay? So now I have to figure out what x is. This is a fraction, so instead of writing it as divided by 2 pi, some of you might prefer writing it as like 1 over 2 pi because it would be easier to use it on the other side. Okay, so cancel out the 2 pi. So on this side, the pi's cancel out. Okay, so that x, that mystery number that multiplied 2 pi was 1 over 6. So there was a horizontal compression by 1/6. Okay, the period became 1/6 of what it used to be. So what value would be in our equation? 6. Okay? The reciprocal of that. Okay? So our final equation looks like cosine 6 in the B value spot. Shift left will end up looking like x plus pi and then minus 1/2. Yeah, so this will not be on the quiz tomorrow, okay? Graphing will be on the quiz tomorrow because we taught it. We did some work in class on it. You guys will get to check it or ask questions. So 2 graphing questions on the quiz, 1 sine, 1 cosine, and then like some stuff from your unit circle. Like what is tangent of 10 pi over 3 or something like that. Okay, you'll get the unit circle, okay? Everybody good and clear? So we're okay with this idea. We'll work on the homework for this tomorrow after the quiz. Okay, it's posted on Canvas. You could start at homework 3, so it's 5 questions about graphing sine and cosine, and then a couple questions about writing equations to keep up your graphing skills in this. Okay. Any other questions about what's happening tomorrow for your quiz? All right, and then just like usual, I'll have a hard copy of the homework here, or it's on Canvas, so after the quiz, you guys can work on that. Okay. All right, I'm going to come around and stamp.